Okay, chapter 6 will start what should be semester 2 in the geometry class, so long as your teacher teaches in the order that the things are listed on the Ohio State website. And chapter 6 is about interior and exterior angles of polygons, any polygon. Because 4 and 5 were about triangles, so this is just all other polygons, regular polygons. And first I'm going to show you how to derive a formula for the number of interior angles in any regular polygon. So, I left my markers up here again. We're going to start with an intuitive method of doing this by saying how many triangles we can fit into the corners of every in the corners of every shape, because we know that a triangle has 180 degrees in it, so we can just see how many triangles there are and multiply that by 180. So let's start simple with a square. Right, if we have this square, and we know in a regular square that all of these sides are the same, but more importantly that all of these angles are 90 degrees. So with that being said, I mean, you can just go, well, 90 times 4 is 360, but if we draw these triangles inside, like this, we can fit one triangle in each corner like that, and then a second triangle in each corner like that. So we can fit two triangles, two groups of 180, and 180 times 2 is 360, right? So that aligns with our 490s as well. But what if we move on to something like a pentagon here? In a regular pentagon, meaning that all of the angles are the same measure and all of the sides are the same length. This isn't a regular pentagon, but a regular pentagon, these would be angled in slightly like that, but you get the picture. If we were to draw as many triangles in here as we can, well, we can put one in this top part up here, and then we have like a square again. So we can do the same thing and put our two triangles down here, like that. And now we have three triangles, three groups of 180. 180 times 3 is 540. I dropped that marker down here, and it landed perfectly upright. I don't know how I did that. Sorry, let me set this camera back up so that it's looking at the board again. Okay. Sorry about that. I thought that was kind of cool. But we have three groups of 180 is 540 degrees. So there's 540 degrees in a regular pentagon. And then let's do one more. Let's do a hexagon here. Like this, and assume it's a regular hexagon, so all the angles are the same. Well, we can fit one triangle in all the corners like this. We can put another one in this corner like this, another one up into this corner, and then back like that. So we can fit 4 triangles in the 6-sided shape. And if you've started to notice a pattern yet, we could fit 2 triangles into 4 sides, we could fit 3 triangles into 5 sides, and we could fit 4 triangles into 6 sides. So we can always fit 2 less triangles than the number of sides there are. So with that being said, we could write out here that it would be, let's say number of sides is n for number. We could do n minus 2 to get the number of triangles that would fit inside. Then we just multiply the number of triangles by 180, and that will give you the interior angles, or the interior angle, the interior angle measure, just like that. So it would be number of sides minus 2 times 180 is the number of the total number of angles, or sum of all the interior angles. And then to find just one angle, of course, you would just divide by n, and that would give you one interior angle, like that. So let's work on a problem here. We have a trapezoid thing like this, like that, and we say that this is this here is x degrees, this is y degrees, this is 100 degrees, and this is 87 degrees, and we'll say this is 110 degrees, like that, this exterior angle. And then I would say solve for x and y, right? Solve for x and y like that. So how would you go about this? If you want to try and figure it out yourself, pause video. Well, what you can start with is see that 110 and x are supplementary, right? So that means that x is going to be 180 minus 110, or x equals 70. X equals 70, and I'll put here in parentheses 70. So now we just have to solve for y. And what we can do here is take the total interior angles, right? We can take the interior angles and then just subtract the y. So what we can do is we can write out here that y plus 100, plus 87 plus 70 equals, and then we go back to that formula we made earlier with the number of sides here, 1, 2, 3, 4, 4 minus 2 times 180, right? And now we can just solve for y like normal. So here we can go, we can say, when we simplify this down, we get y plus, what was it, 257 equals 180 times 2. Because when you subtract, right? Now, from here, 180 times 2, y plus 257 equals 360, like that. And then we say, we just subtract from there and say y equals 103 when you do 360 minus 157, or 257, like that. Y equals 103. So you can write that out here as your answer. Y equals 100, or I already have y equals 103 degrees. And that would be how you solve something like this here. Solving for y, you would take that formula, set it equal to what you already know, and then just solve for your variable. Next, I don't know if I have another problem, a practice problem for you, or if we're going to move to the exterior angles. Let's see. Yep, so now moving on to the exterior angles. So the exterior angles of any shape, and what we mean by exterior angles is if we have a shape, I'll just do, I don't know, parallelogram, just choose something, right? And then if we take this and extend it out in any direction like this, this, and this, so you extend any set of sides, the exterior angles would be these right here. And for any shape, the sum of the exterior angles is 360 degrees, because if you go all the way around the shape, right, you're going all the way around, you're going to go in a circle, and a circle is worth 360 degrees, or 2 pi radian, if you're doing radian. Right? And to further prove this, if our shape is, just a line, like this, well, actually, let's make this a segment rather than a line. To go all the way around this, your angles would have to be, that's an exterior angle, and that's an exterior angle, and you just end up making a circle, right, with this being the diameter. So that's 360, and then as you add another side, well, in Euclidean geometry, you can't have a shape with 2 sides. In non-Euclidean, you can, but if we go up to 3 sides, here, a triangle, as you go around like this, you can see this, this, and this. Those are each about a third of a circle, and they make 360 degrees. And there are good animations out there of people drawing this, and then they take the angles and turn them into a circle. But you can see how each part of this would be a circle. This part would connect here, and then this here, and this here, like that. If you shift it all together, it makes a circle, and hence 2 pi radian, or 360 degrees. So with that being said, if I give you a practice problem to work on here, we'll work with a triangle again. Let me move that up a bit. We have our triangle, like this, and we extend out our sides here. Yeah, I don't know what I was thinking. Like that. That one's a bit crooked, but I ran out of space at the top there. Like that. And our angle measures are z minus 3 degrees. This is w degrees. This up here is x degrees. This is y degrees. And then this here would be z plus 10 degrees. And then up here we have z degrees, like that. So if you want to try to work this out by yourself, pause the video here to figure it out. Okay, now I'm going to work through it. So first we need to solve for our exterior angles, and we know that all of these added together is going to equal 360 degrees, right? So we go z minus 3 plus z plus z plus 10 equals 360, or 360, because those are the exterior angles, and as you go all the way around the circle. Now from here we can just simplify this out to, because there's 3z, so we get 3z, and then we take the -3 plus 10, goes to plus 7 equals 360, like that. Then from there you do 360 minus 7, so 3z equals 3z equals 352, like that. And then 352 over 3 is 121. Yeah. Z equals 121. Right, let me check this to make sure I did that right. Minus 3. Oh, yeah, I did it wrong on my notes. I forgot about the 10 and just did the -3, but you get the same answer. Well, I have the wrong answer written down here, but it's the correct answer that I copied off the website. So we know that Z equals 121. So up here we can write 121. Then 121 minus 3 is 108. So we can write up here 108. And then here 121 plus 10 is 131, like that. And then from there, we can just go and use supplementary, because all of these angles are going to be supplementary to all of each other. Wow. Fix my grammar. Right? So here we can do 180 minus the 108 is W equals 72, like that. Then Y would be 180 minus 131 is 49. And then X would be 180 minus 121, or 59. Yeah, like that. And then from here, if we want to check the work, we can see, do I have my calculator up here? I do. We can do, 72 plus 49 plus 59. So 72 plus 49 plus 59. And that equals 180. I don't know if the camera's going to focus on that. So that should be correct, because we know triangle is equal to 180. And then the same thing here, we can add all of these exterior angles together. So we can do 108 plus 131 plus 121. And we see, again, I don't know if it's going to focus, but that equals 360. Just like that. And let's see. Now I have some questions for you. And then on to chapter 7. So, question 1. What is the exterior angle, or what is the area of one exterior angle of a hexagon? So think about it for a minute. The exterior angle of a hexagon would be, the entire exterior angle would be 360, and a hexagon has 6 sides, and therefore 6 exterior angles. So you would do 360 over 6, which is 60. So one exterior angle of a regular hexagon is 60 degrees. The second question is, what is the interior angle of a regular pentagon? Interior angle of a regular pentagon. So if you think about it for a minute, you get, first we have to calculate the total interior angles. and a pentagon has 5 sides, so it's 180 times 3, which is 540 degrees. So the total of a regular pentagon is 540 degrees. Then you just divide that by 5, and you get that one interior angle of a regular pentagon is 108 degrees. And finally, then you get to chapter 7. Finally, how many sides does a regular polygon with an exterior angle of 30 degrees have? So if it's regular and the exterior angle is 30 degrees, what we would normally do if we had the side, is we would do 360 over the side equals our angle measure, but our angle measure in this case is 30 degrees, right? So then from here, we can just we multiply by s this way. 360 equals 30s, not 38, 30s like this. And then we just divide by 30, 360, 60 over 30 equals s, not 8, like that. And 360 over 30 is 12. So it would be a 12-sided shape, a dodecahedron, I believe that would be called, has an exterior angle of 30 degrees. And to check 30 times 12, just do this in reverse, and you get 360. And with that, that's the end of Chapter 6, Interior and Exterior Angles of Polygons. Chapter 7, let's see what Chapter 7 you get into. Chapter 7 is dilations. Dilations is okay.